Hi students, this is Alex here. In this video, we are going to verify Gauss divergence theorem for f vector, which is taking over the region in the first octant bounded by y square plus z square is equal to 9 and x is equal to 2. Now, let's write the Gauss divergence theorem, which is double integral over the surface S f vector dot n cap ds equal to triple integral over the volume V del dot f vector dv. Now we are going to construct a small diagram for the given first octant equation y square plus z square is equal to 9 and x is equal to 2. So for this we are going to take a three-dimensional axis. We have y axis, z axis and x axis. So here we name this as y, this is z and this is our x. And as usual we have the unit vector I cap along the x axis and j cap along the y axis and k cap along the z axis. And this is an equation of circle in the yz plane. So let's write the equation here. Then it is y square plus z square equal to 9 and its center is the origin 0, 0 and the radius is 3 units. So we have a circle in the yz plane. So it is in the yz plane like this with radius 3 units. So it is something like this. And if I take this point as A and this as B, so this point is on the y-axis. So 0, 3, 0, the radius is 3 and this is on z-axis. So 0, 0, 3 and we have x is equal to 2. It means this equation, this bottom surface equation is x is equal to 0. So let's write the equation here and x is equal to 2 will be the one which is above this. With the same size I take a circle and it is above this like this. Now if I join this one we get a full cylinder and this equation is x is equal to 2. But here we are going to consider only the first octant. So the base region is this alone. And in the same way, in the top region also, when it is x is equal to 2, we get something like this. And to exactly draw the first octant, we join this, then we join this. So this is our first octant. So already we have shaded the bottom region and this is our top region. And in this we have the back side region is this one, and we have, there is a surface which I marked with a different color, this one. So these are the regions we have, and this is a curved region also. So when I take the left hand side of the Gauss divergence theorem, it is double integral over the surface S f vector dot n cap ds. First let's take the bottom region. So in the bottom region it is f vector dot, and bottom region when we take the unit vector which is going in a downward direction and it is opposite to that of the x-axis, that is I cap. So it will be minus I cap and this is having the dimension y and z. So dy dz. So this is our bottom surface. And coming to the top surface, once again it is the same thing. This is the top surface and it is f vector dot now I cap, because here it will be in the direction of I cap, this top surface is having a normal vector which is in the direction of I cap, and it is also having dy and dz. Then I take this left surface, so it will be plus double integral. I take this as the left side, which is f vector, and this surface will have a normal vector which is pointing in this direction, which is opposite to that of k, which we can see it here. K is here, so this is opposite to that of k. So we take this as minus k cap, and this is having a dimension y and x. So dx dy, and in the same way this backside surface, this surface, so this surface will be having a n cap projecting in opposite to that of j direction, because it has to go away from the surface and it is opposite to that of j. So we take this as double integral back surface f dot j, and that surface is having the dimension we can see from the diagram z and x. So dx dz, and the last one is this curved part which is here. The curved part is facing this way. This is the curved part, and this will be from the diagram double integral. We take the curved part f vector dot n cap ds. So 1, 2, 3, 4, 5 regions we have. So bottom, top, left side, back side, and this curved part, because all these things cover the first octant. Now for every surface we have an equation. So for the bottom surface we can see it is x is equal to 0, which we have to write it here. This is x is equal to 0, and the top surface it is x is equal to 2. You can see from the diagram. In the left side it is on the y-x plane. It means the value of z is 0. And in the right side it is on the xz plane. So y is 0. And in the curved surface it is the cylindrical part, so whose equation is y square plus z square is equal to 9. Now we have to work out each part. We will take the first part I1, that bottom surface. So I1 equal to double integral. We have f dot minus I cap. From the question we have this is f vector. When it is minus I cap, we have only 2x square y. So this is 2x square y with a minus sign because minus I cap. Then we have dy dz, and x is equal to 0 is the equation. Since x is equal to 0, when we substitute x as 0, then the entire integration is 0. Now coming to I2, which is on the top region, x is 2 here, it is f dot I cap, so the same thing will come 2, and x is equal to 2 is the equation, so 2 square. So let's write first as it is, then we will go for substituting the x value. So 2x square y dy dz, and the equation of the plane, that surface is x is equal to 2. And we have to substitute the limit of y, that we can see from the diagram, that is y varies from, the value of y varies from here to here. So here the value of y is 0, but here it is root of, from this equation the value of y is 9 minus z square. So it varies from 0 to root 9 minus z square. So we have to write this as 0 to root 9 minus z square, and z varies from 0 to 3. So this will be from 0 to 3. Now we have to substitute the x, which is 2 here. 2 square is 4. 4 2s are 8. So it is 8y dy integral 0 to root of 9 minus z square. Then we have integral 0 to 3 dz. So first integration we have to evaluate with respect to y. It means it will become 8y square by 2, and it is from 0 to root of 9 minus z square. And still we have outside integral 0 to 3 and dz. When we substitute the upper limit, it will become 9 minus z square, and outside we can cancel this, it becomes 4. Now we have integral 0 to 3, and when I put the lower limit, everything is 0. So we have left only this part, and with respect to z, if I integrate 4 into 9z minus z cube by 3, 0 to 3. So 4 into 9 into 3 minus 3 cube by 3. So 3 cube by 3 we can cancel. So this becomes 4 into 27 minus, after cancelling this is 3 square, which is 9. So 27 minus 9 is 18. 18 into 4, 72. Now coming to the I3. So I3 is, we have finished I1 and I2. Now I3 is left side, that is double integral. We have f dot minus k. From the question, the k coefficient is 4x z square. So it is 4x z square with a minus sign, and we have an equation for this surface which is z is equal to 0, and this is with respect to dx, that is x and y, dx and dy. So dx dy, since z is 0, entire term is 0. Now coming to I4, which is f dot j, and y is 0. So double integral y is 0. From the question it is minus y square, the coefficient of j. So minus y square and dx dz. This is dx dz. Since y is 0, everything becomes 0. Now coming to the last part, which is the curved surface f dot n cap ds. So I5, we have double integral f dot n cap ds. Let's find what is n cap, which is del phi by magnitude of del phi, and phi is, from the equation we can take y square plus z square equal to 9. So phi from this is y square plus z square minus 9. So del phi becomes, we can calculate here, I into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z, the whole thing into y square plus z square minus 9. Now dou by dou x of this is 0, so I cap into 0 plus j cap into 2y plus k cap into 2z. So we can take 2 common, so it is y j cap plus z k cap. Now magnitude of this del phi magnitude, this becomes 2 root of y square plus z square, and this is 2 root of y square plus z square value is 9 here. So root 9 is 3. Totally this is 6. So from this we get n cap as 2 into y j cap plus z k cap by 6. After cancelling this, y j cap plus z k cap by 3. And we also need f vector dot n cap. So we copied the f vector here. Dot n cap is y j cap plus z k cap by 3. So this will become j and j if I multiply minus y cube by 3. Then 4x z square into z is z cube by 3. So we got f vector dot n cap here. We also need ds. ds we can take dx dy by n cap dot k cap, or we can also take dy dz by n cap dot I cap within the mod, or we can also take dx dz by n cap dot j cap. Since this n cap is having only j and k, we cannot take this I. Either we can take n cap dot k cap or j cap. So let's take the first one, that is ds equal to dx dy by, when I do n cap dot k cap with this, we get z by 3. So it is z by 3. So finally ds is 3 by z dx dy. So coming to the integration, we have double integral f dot n cap is minus y cube by 3 minus y cube by 3 and plus 4x z cube by 3 plus 4x z cube by 3 f dot n cap into ds. ds is 3 by z dx dy. The limit of y from the question we can able to see it starts from, limit of x is starting from 0 and ending at 2 for the x. So the limit of x is 0 to 2. Let's write it here, 0 to 2. And limit of y is the radius part of the circle, which is 0 to 3. So we take 0 to 3. Now we also have the equation of the surface, which is y square plus z square equal to 9. Now let's simplify this further. So integral 0 to 3, integral 0 to 2, and when I multiply 3 by z here, we get only minus y cube by z. 3 gets cancelled, and even here it is 4x z square. 3 gets cancelled, z also z cube by z is z square, and we have dx dy. Now I have to change everything in terms of x and y. So we have to replace z from the equation. Z square is 9 minus y square and z is root of 9 minus y square. So when we substitute, this is integral 0 to 3, integral 0 to 2 minus y cube divided by root of 9 minus y square plus 4x into z square is 9 minus y square alone, and we have dx dy. Now first we have to integrate this with respect to x. It means y is constant. So we have outside integral 0 to 3, and this entire term is constant. So constant integration is constant into x, and here 4 into 9 minus y square is a constant, and x integration is x square by 2. We have to apply the limit of x 0 to 2, and outside we have dy. we are going to substitute the limit of x, that gives minus y cube by root 9 minus y square into 2. Lower limit is 0. And when I put 2 here, 2 square is 4, 4 by 2 is 2, 4 are 8. So we have 8 into 9 minus y square into dy. Next part, we are going to evaluate the integral with respect to y. So for that, we have to split the first part as 2 is taken out, and integral y minus y cube can be written as y square into minus y divided by root of 9 minus y square, and we have dy. This purposely I have split it because we are going to give substitution for the integration. So y cube is split into y square into y, and there is a minus sign I have taken along with this y. And second part, we have 8 outside, then integral 9 minus y square into dy. Now in the first part, we are going to take substitution t, which is root of 9 minus y square. From this, dt is 1 by 2 root 9 minus y square into minus 2y dy. We can cancel 2 and 2. Now we find this entire term is dt. So we can say this is 2 integral, this is dt, and the original limit is 0 to 3. That will be here as it is. This is the limit of y. But y square I have to square this and take. That is t square is 9 minus y square, and from this y square is 9 minus t square. So this is 9 minus t square, and the rest of the term, that is minus y dy by root of 9 minus y square is here, which is nothing but this dt. So it's a basic integration substitution. And now we have to change the limit y and t. The limit of y is from 0 to 3. When I put y as 0 in this becomes root 9, which is 3. When I put 3 here, t becomes 0. So our limit changes from 3 to 0. We have outside 2, and we have in terms of t, and this is as it is, integral 0 to 3, because it is already with respect to y. So now we are going to continue this integration. First is with respect to t, second is with respect to y. This is 9t minus t cube by 3 to 0, and this is 9y minus y cube by 3, and this is from 0 to 3. When I apply the upper limit, everything is 0. When I apply the lower limit, it is 27 minus 27 by 3, which is 9, bracket close. And here when I apply the upper limit, it is 27 minus 27 by 3 is 9. When I apply the lower limit, everything is 0. So this is 2 into minus 18, and this is 8 into 18. So we can take 18 common. This will become minus 2 plus 8. So it is 18 into 6. When I multiply, 8 6 48, and 6 ones are 6. So 108 we get. So finally the value of I5 we got as 108. Now complete LHS, we have I1, I2, I3, I4, I5. So we are going to add everything. So I1 is 0, I2 is 72, I3, I4 0. Let's write it here. This is 0, this is 72, this is 0, 0, and 108. So by adding this, we get 180. Now we are going to take the right hand side of the Gauss divergence theorem. The right hand side is, we have triple integral over volume del dot f vector dv. Now we have triple integral. Del is I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z with this dot of this f vector. Then we have dv. dv is dx, dy, dz. Now I dot I, so this will become 2x square y dou by dou x. Then there is a minus sign, then dou by dou y of y square. Then last is dou by dou z of 4x z square. Then the entire thing triple integral over the volume V dx, dy, dz. Now doing partial derivative with respect to x, so 2y is a constant and x square derivative is 2x. Here it is 2y and here it is 4x is a constant and 2z. The entire thing into dx, dy, dz. We have integral, triple integral over the volume. Now just rearranging this, it is 4xy minus 2y plus 8xz into dx, dy, dz, and the limit of x varies from 0 to 2 and limit of y varies from 0 to root of 9 minus z square and z varies from 0 to 3. Already we have discussed this limit from the diagram. X varies from 0 to 2, y varies from 0 to root of 9 minus z square and z is varying from 0 to 3. Now first part we are going to evaluate this with respect to x. So it means other than x are constants. So here it is 4y is a constant. Integration of x is x square by 2 minus 2y into x, because constant integration constant into x. Here 8z is a constant and x integration is x square by 2, and we have the limit for x which is from 0 to 2, and the rest of the terms are written as it is along with the integral and the limit, and outside we have dy, dz. Now applying the limit of x here, it will become 4y into 2 square by 2 is 2 square is 4, 4 by 2 is 2. Then here it is 2y into 2. Then here it is already this is 4. When I apply 2 here, 2 square is 4, 4, 4, 16 into z. And we have integral 0 to root of 9 minus z square, integral 0 to 3 dy, dz. Now again rearranging this, this is 8y minus 4y plus 16z dy, dz, 0 to root of 9 minus z square, 0 to 3. Now totally this is 4y plus 16z, and we have integral with respect to y, which is limit varying from 0 to root of 9 minus z square and 0 to 3 for z. Now next part we are going to evaluate this alone, that is with respect to y. It means y becomes 4y square by 2 and constant is 16z into y. Now we are going to apply the limit which is from 0 to root of 9 minus z square, integral 0 to 3 dz. After cancelling this, when you apply the upper limit, this becomes 2 into 9 minus z square plus 16z into root of 9 minus z square and integral 0 to 3 dz. Now we are going to split this into two parts. 2 integral 0 to 3, 9 minus z square. This is the first part, and we take this as dz. Then this is 16 is taken out, integral 0 to 3 z root 9 minus z square dz. This first part is 9z minus z cube by 3, and outside we have 2, limit is from 0 to 3. And this one we have to take this as 9 minus z square as t. So dt will become minus 2z dz. So this will be 16 outside. This z and dz is here, which is dt by minus 2, and this is root t. And we have to change the limit. When z is 0 here, t becomes 9. When z is, let's write it here, z and t, and limit of z is 0 to 3. When z is 0 here, t is 9. When z is 3 here, t is 0. So 9 to 0 is the limit. Now finally, when we substitute the limit for the first part, this is 27 minus 27 by 3 is 9. Lower limit everything is 0. And here it is minus 16 by 2 is minus 8. And we have t power half, which is t power 3 by 2 by 3 by 2. And limit is from 9 to 0. This is 18. So 36 minus 8 into 2 by 3, and 0 power 3 by 2 minus 9 power 3 by 2 after applying the upper limit minus lower limit. So this is 36 minus 16 by 3, and this is minus 3 square for that power 3 by 2. So we can cancel this 2 and 2. This is 27, and there is a minus sign, so it becomes plus 36 plus 16 by 3 into 27. Can cancel this 9 times. This is 36 plus 144. After adding this, we get 180. So already LHS we got 180 and RHS also 180. So we can say LHS equal to RHS. Hence, the Gauss divergence theorem is verified.